In the next few minutes, I'm going to show you exactly how Jensen Huang's latest prediction will transform 3 specific areas of your home life by 2025. First, we'll explore how your AI assistant will revolutionize energy management, potentially cutting your bills by 30% without any effort from you. Then, we'll dive into predictive maintenance that could save you thousands in emergency repairs. Finally, I'll reveal the most exciting part: how your home will create personalized environments that adapt to your mood, schedule, and preferences in real time. The godfather of AI has spoken, and your home will never be the same. Here's the dirty secret that smart home companies don't want you to know. Most homeowners spend more time managing their smart devices than they ever did with traditional switches and thermostats. You bought into the promise of automation, but you're actually doing more work than before. Walk through any modern smart home and you'll find a collection of isolated islands. Your Nest thermostat operates on its own schedule, completely unaware that your smart lights are programmed to turn on at different times. Your security system runs independently of your door locks, even though they should coordinate seamlessly. Each device requires its own app, its own settings, and its own constant attention. The average smart homeowner juggles between 8 and 12 different apps just to control their connected devices. Your morning routine involves checking the thermostat app to see why the house feels cold, opening the lighting app to adjust yesterday's automated schedule that didn't account for the cloudy weather, and manually overriding the smart irrigation system because it can't distinguish between a brief shower and actual rainfall that would make watering unnecessary. Smart thermostats represent the perfect example of this contradiction. These devices cost 3 times more than traditional thermostats and promise to learn your schedule automatically. Yet most homeowners find themselves constantly adjusting settings because the thermostat can't handle the complexity of real family life. It doesn't understand that Tuesday piano lessons mean everyone comes home 2 hours later, or that working from home on random Wednesdays requires different temperature settings throughout the day. The learning algorithm assumes consistency that doesn't exist in actual households. Smart lighting systems follow similarly rigid programming. Your automated evening lighting routine triggers at sunset regardless of whether you're hosting a dinner party or trying to put young children to bed early. The motion sensors turn on bright hallway lights at 2 a.m. when you're trying to quietly check on a sick child. These systems execute commands without context, creating situations where manual override becomes the norm rather than the exception. Research from Parks Associates reveals that smart homeowners spend an average of 23 minutes per day actively managing their automated systems. That's nearly 3 hours per week dedicated to devices that were supposed to eliminate manual control. The study found that 47% of smart homeowners regularly disable automated features because they create more problems than they solve. The frustration runs deeper when you examine actual user satisfaction data. Amazon's internal metrics show that 31% of Alexa users interact with their devices less than once per week after the initial 3-month honeymoon period. Google reported similar engagement drops, with most home device owners using fewer than 4 voice commands regularly. The most common commands remain basic requests like weather updates and music playback, not the sophisticated home management tasks these systems were designed to handle. Smart home marketing promises seamless integration and intuitive automation, but the reality involves constant troubleshooting, device conflicts, and scheduling adjustments. Your smart doorbell doesn't communicate with your smart garage door opener, so deliveries still require you to manually override systems to grant access. Your smart smoke detector can't coordinate with your HVAC system to prevent spreading smoke through air ducts during an emergency. The current approach treats each device as an independent entity that happens to connect to your Wi-Fi network. Integration exists only at the surface level through shared apps or voice assistants that relay commands between systems. True intelligence would require these devices to understand context, anticipate needs, and coordinate responses automatically without human intervention. The mental load of managing these systems often exceeds the convenience they provide. You remember when adjusting your home's temperature required walking to a single thermostat and turning a dial. Now you need to navigate app interfaces, check connectivity status, update firmware, and troubleshoot device conflicts when systems stop responding to commands. Current smart assistants respond to direct commands but lack the sophisticated reasoning needed for proactive home management. They can tell you the weather forecast but can't connect that information to your irrigation schedule, indoor humidity levels, and energy usage patterns to optimize your home's response automatically. This manual approach to managing automated systems creates a fundamental contradiction that prevents smart homes from delivering their promised benefits. Homeowners become system administrators for technology that should work invisibly in the background. The three areas where current smart home technology fails most dramatically are energy management, maintenance monitoring, and environmental personalization. Your thermostat can't coordinate with your water heater to optimize overall energy usage. Your appliances can't predict their own maintenance needs or communicate potential problems before failures occur. Your lighting and climate systems can't adapt to your actual preferences and routines without constant manual programming updates. Jensen Huang's prediction addresses these exact limitations through AI assistants that understand context, learn genuine patterns, and coordinate responses across all connected systems simultaneously.